everyone, welcome to today's optics session, the session number 1, where we are going to see a lot about reflection, be it from lakes, plane surfaces. Just look at these stills, guys. It's so amazing to see all of this beautiful reflection images out here. And I'm pretty sure after today's session you will no longer be scared to solve problems on reflection. That's my aim. And guys, this is Shreyas here, your master teacher for physics at Vedantu, going live. How is everyone? How are all my minions out here? Hi Yalni, Pravenshi, Bastin, Magical Paintbrush, Tanmay. Hello Jayesh, Manish, Mohit, Science Priya. Hello guys, everyone. Welcome, welcome, welcome. Remember, the only way I will know that you guys are here is only when you put your comments in the chat box. Yes, it's a live chat box and you are attending a live session. So come on, interact with each other, make some friends. We call ourselves the minions out here. So guys, yes, welcome to Enthuse, which is a very unique channel because it is a one-stop solution for all the JEE and other competitive exams like BITS, SAT, KVPY and boards. So we are going to make sure that you are very well prepared. And the speciality is that we teach you in English out here. So welcome. And guys, if you still want to get in touch with me and you have some queries or you want to just ask something, definitely feel free to contact me on my Instagram handle. That's Shreyas_Vedantu. Hi Kevin, hi Yogesh, hi Gayatri. Welcome new students, welcome. And you should probably introduce yourselves to others so that you can make a lot of friends out here. And before we begin, remember, you should hit the subscribe button. Only then you will get more and more updates. One such update will be coming very shortly, especially for the 12th standard and the dropper students. And also guys, since you're already here and if you have already hit the subscribe button and if you have not yet liked, please go ahead, smash that like button, make it from gray to blue if you have not done it yet. Okay, because we are going to get all that energy from your love, your support and all the likes out here. Hi Dhruv, hi Aishwarya, hi Princey. Hello everyone. Hi Kirito. Watashi wa kita. Hi Chakri. All right, very good, very good. So the schedule for the week is out. So we are having a lot of KVPY sessions and we are going to have optics related sessions today, tomorrow. Today is everything about reflection. Tomorrow, single surface refraction. On Friday, a marathon session on prisms, that is two surface refraction and lenses, as well as PYQs, that is previous year's questions, and KVPY sessions on Thursday and Saturday as well. You will get all these details in the session PDF in the description box below. So after the session is over, even on our Telegram channel, everything gets updated. So you know when and where the lecture is. So the marathon sessions are power-packed sessions, long sessions, so that you learn a lot in this duration. So Thursday will be by Shimon sir, Friday will be by me, and Monday will be by Wazim sir. So that's the schedule. So let's begin with our class, guys. I hope the Josh is high and keep interacting and stay till the end because you're going to learn a lot. Not just plane mirrors, but also curved mirrors and some really cool special problems for all of you. Hello Ankit, Bhargav, Divya, welcome, 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 welcome. Very good. So time management, Saurabh, you nailed it. I have exactly just made a video on time management. You just go ahead to the past videos. You will see how to manage time and make schedules and delegate tasks, etc. I have made a video on that. Please check it out. Okay, fine. I hope I have answered your question. Okay, cool. Now let's talk about plane mirrors first, and then we'll make the mirrors curved. So we'll deal with concave and convex next. Now there are so many amazing questions just on plane mirrors. You will be amazed to see all of them. But before that, let's go with the theory. So that's very important. We'll quickly revise the theory and then we'll go to problems. So first, laws of reflection. Any reflecting surface, be it plane or be it curved, has to follow these two laws of reflection. What are these two laws? Number one, the angle of incidence. So if a ray falls on a reflecting surface, if you draw a normal, that angle which it makes is called as angle of incidence. And after reflection, the angle which it makes with the normal is called as angle of reflection. They both have to be equal. And also the incident, normal and the reflected ray lie in the same plane. So that is very important. And like I said, it is not just for plain mirror but also for a curved mirror. What do I mean by that? See guys, now this law is generally shown for a plane mirror. Incidence is equal to reflection, and this ray and this ray are all in the same plane. But understand, even if the surface is curved, okay, and if you have a ray which hits over here like this is the incident ray, if you draw a normal at that point, you will see the reflected ray will still obey the laws of reflection. Over here, if it hits it, you should just draw a normal and again show the reflected ray. So it's valid even for a curved mirror, because a curved mirror is also made up of small plane mirrors. Okay, so that is your law of reflection. I hope you guys are understanding this. Ayman, you're not late. I just started the session just a minute or two back. Okay, so Ankit will be conducting mentees very soon, but this week we want to focus more on some strategies and some special sessions. That's why we don't have mentee this week. Okay, don't worry about it. Okay, cool, no problem VK, just join in. You have probably missed a minute or two. Okay, next, some important properties from a plane mirror, guys. Obviously the image is erect. You will never see that you're standing in front of the mirror and you see yourself upside down. That would be weird, isn't it? So always when you stand in front of the mirror, wow, she's checking herself out, and you will see that she will see herself upside down. She won't see her feet there and her head down. That would be weird. Next, very important, the image size is same as the object size. So if you see yourself in the mirror, the person in the mirror will always be, that virtual person will always be of the same size. You might say, oh no, in this mirror I look fat. Oh, in this mirror I look thin. There is nothing like that. If that mirror is perfectly flat, then you'll always see yourself of the same size. You will never see yourself small or large. Understand that. That's another speciality of plane mirrors. Oh, Ankit, should I go really slow? Okay, fine. I mean, you will also get all the notes, Ankit, but yes, you can make a little bit fast notes if possible, because these are some basic properties. So that's why I thought I can quickly go through it, brush through it. Okay, cool. Okay, no problem. I'll go a little bit slow. No problem, guys. Fine. Okay, cool. Okay, feedback taken, Ankit. Okay, now the next thing that is very important is what is the depth from the image, from the mirror. If you're standing at certain distance from the mirror, you will see yourself behind the mirror at the exact same distance. So if you are seeing another object, then that object's image will be at the same distance behind the mirror as the object is in front of the mirror. Very important. Also, there is one more important property which I probably not put in the slide, but you should note it down, and that is that the image is laterally inverted. Very important. It is laterally inverted. Now let me tell you one thing, many people don't really understand what is the meaning of lateral inversion. You know what they say? Left becomes right, right becomes left. Because if you lift your right hand in front of the mirror, the person inside the mirror feels as if he's lifting his left hand. Isn't that correct? But that is not the exact way or method of understanding what is lateral inversion. I'll tell you what it is exactly. Understand, no problem, Sneha, join in. So I'll tell you what exactly it is. Have you ever noticed that there is a right shoe which is different, left shoe which is different? Also the right glove is different, left glove is different. Right socks are different, left socks are different. Isn't that correct? Your right earbud is different, left earbud is different. Now imagine I give you a right hand glove and I ask you wear that right hand glove on the left hand. One side is, let's say it can only bend like this, it can't bend like that. So you have a right hand glove, it's same color everywhere. I ask you to wear that right hand glove on the left hand. If you think that, okay, I will take that right hand glove and put it over here, understand the moment you wear it, assuming that it can only bend on this side, the moment you wear it, you will not be able to bend your hand. Think about it. If you have a right hand glove which can bend like this, just try to put it over here. Your left hand wants to bend like this. but that glove will bend here, so it will not exactly fit. But imagine you place that glove in front of the mirror. What the mirror exactly does is as if somebody is putting their hand inside and pulling that sock or that glove or that shoe or whatever that item is inside out. It's as if somebody pushed their hand inside and pulled it inside out. So that right hand glove, when you pull it inside out, it will become a left hand glove. Think about it. So what a mirror does is when you stand in front of it, it is pulling you inside out like this, so that the image feels as if the left became right and the right becomes left. That's what happens. It pulls you inside out. Think about it. My nose, okay, will be pulled inside out. It goes there, you know, my eyes goes there, everything. It gets pulled inside out and you will see the reflection. I hope this is clear. Oh, it's scary. I know, kind of. Okay, cool. Next important property, guys, the image. Yes, the image size and object size are always equal. Pravenshi, I just mentioned that. Yes. Okay, cool. The image moves with the same speed as the object moves, because think about it, image distance is equal to object distance. So if object moves closer, image also has to move closer. If object moves away, image also has to move away. They will move with the same speed to make sure image distance from the mirror is equal to the object distance from the mirror. This is all with respect to the mirror. Please understand that. We'll be solving problems where even the mirror is moving, and then let's see what to do in those situations. All right, great. Now, another important property that you must note down is the angle of deviation. If the ray is incident like this, it reflects like this, the ray wanted to go there, but it deviated like this and went like this. So this angle, so the angle by which it tilts eventually is called as the angle of deviation. Remember that. And since this angle of incidence and this angle of reflection are exactly equal, so this angle must be 180, because 180 is the total angle, minus 2 theta. So angle of deviation from a mirror is 180 minus 2 theta. That is what you should note down. Yes, you can keep a mirror besides you. I'm pretty sure most of you will be in your bedrooms where there is a mirror or a dressing mirror out there, and you can see all these things happening. Correct. Cool. So if you take a laser and if you point it, you will see the deflection will be by 180 minus 2 theta. Another important property, which is called as the virtual image property. So guys, if you are, I'm very good, Suru, thank you. Yes, Dhruv, I'm planning to complete as much as possible by 31st, because our final goal eventually is JEE, but I'll try and complete or take some special sessions for complete revision. Don't worry, Dhruv. Now, oh yes, if you change the position, the image size will change. But whatever is the object size over there, you will see that the image size is the same. Understand that. Okay, so obviously if I hold this pen closer, it will appear larger, but if I take it far away, it appears small. Does it mean it has actually become small? No, right? So same thing, if object moves away, image also moves away, it appears to be small, but actually it is of the same size as the object. Understand? Just because it is far does not make it small. Okay, cool. So you can bend laser light using refraction and reflection. Okay, now virtual image means what? The rays appear to come from or appear to originate from some point. Okay, you cannot feel it, you cannot touch it. Obviously, the person inside the mirror, I mean, I'm pretty sure you would wish that the person exists in reality and he does all the work of your room, he cleans all your room, he does all the studies, and meanwhile you just sit over there, relax, so he does all your job. But unfortunately that does not happen. It's a virtual person, and if you are angry at yourself, you cannot hit yourself in the mirror. Nothing will happen, guys. That is a virtual thing. Remember that. Okay, cool. Yes, that will be scary if that happens, the person inside the mirror comes to reality. I'm pretty sure that will be a horror movie. Okay, so now let's start with some problems, guys. Get ready for some problems. And I know a lot of 12th standard and the dropper students are also here. So let me also tell you that, we also encourage students to, for the final push before the JEE Mains examination, we encourage the students, if you want that final push, you can definitely join the crash course. And in this crash course, why am I telling you about this? In this crash course, guys, there are 45 live interactive sessions where a master teacher like me, I know these teachers really well because they have been with me for a long time. And these teachers teach you simultaneously. You have another teacher who will be solving all your doubts. That's very important. And after the class is over, you get something called as a doubt app. In that doubt app, you can instantaneously message, send screenshots and get all your doubts, queries resolved. That's very important. No matter how many doubts, it's unlimited. It's not like for 10 doubts you have to pay more extra, nothing like that. Also, you have, almost like 15 to 20 test series, full and part syllabus. And after every test, you have discussion of that test. Also, you get detailed analysis on how much time you spent on each question, how many questions are done wrong, and how is your accuracy. So since everything is computerized, the artificial intelligence tells you what you can do better, and the report card is a lot more in detail than your regular report cards. And also there will be special sessions by Anand Sir, Pulkit Sir and all our other great master teachers for the final leap just before your JEE Mains examination. So all of this in a power-packed session, 45 sessions apart from the extra sessions that you're going to get with doubts and all of this, only for 10,000 rupees, but with the coupon code SHCC21, if you use, then you will get the crash course for 8,000 rupees. Remember, a new batch will start on Monday. Every Monday a new batch starts, so you do not miss anything. As such, if you join even a little bit late, it's okay, just that your portion will get completed 1 week later. That's it. So that's the only difference. It's a cyclic order. That's how this crash courses have been designed to be modular in nature. And the best part, guys, the crash courses are available for Hindi speaking students separately and English speaking students separately with separate set of teachers. Yes, so that's why I'm telling you it's very important you go check it out. RLN, he will be taking classes, strategy sessions any random time. I mean, that will be informed in the schedule, but that has been planned. Okay, so Anand sir will also be taking. Yes, correct. Okay, hi Romel, Jai Hind. Okay, angle of deviation, Pravenchi, I'll tell you what. See, if Pravenchi, if the incident ray is coming like this, it wants to go there, but because of this mirror, it got reflected. So the intended minus that actual path, that angle which is there is called as angle of deviation, which is 180 minus 2 times angle of incidence. Okay, cool. Now, virtual image and virtual object, guys, very important for all of you to note this down. Very important. Very important. This candle is an actual object. The rays from that candle get reflected and fall in your eyes. Now, the first thing that is happening is reflection. The second thing that is happening is refraction in your eyes. There are two events here, reflection from the mirror, refraction in the eyes. For this object, this image is virtual because the rays appear to originate from some point, okay, which is there behind that particular mirror or that lens, whatever it is. So if you extend those rays, it appears to originate. So for a virtual image, understand it appears to originate when you extend the rays backward. Now this image is an object for my eye. Very important. A virtual image becomes a virtual object in this case now, okay, for my eye. Understand that. So very, very important for all of you to note this down, because for when there are multiple things happening, refraction, reflection, refraction, refraction, etc., the image of one becomes the object for the next event, and the image for the next becomes the object for the next event. So that's how it happens. So this image, because of the mirror, becomes the object for my eye in the next event of refraction. Same way, real images and real objects. Now, a lot of people have this common misconception that real images can be seen only on a screen. That is wrong. That is wrong. Sai Surendra, please don't spam, but objective and eyepieces will be talked about in optical instruments, not now. Okay, so a lot of people think that if you have a real image, then you need a screen to see that real image, just like the setup over here. But that's not true. Remember that. Because what is the meaning of, true meaning of real image? Real image means the rays actually converge at a point. And if you place a screen at that point, you will see the image. That's what real image is, where the point where actually the rays converge is called the point where you will obtain the real image. But remember, if you do not place a screen there, what will happen? Those rays will meet and they will go like that. Then it will feel as if the rays are originating from this point. Think about it. Think about it. If you do not have a screen, the rays will continue going, and if this is your eye, think about it, it will feel as if the object is over here. That's what will happen. So you can actually see a real image if you do not place a screen and if you are standing at a point behind that point. That's very, very important. Thank you, total of. I hope this is clear. Yes, yes. So that's why you are able to see this house and this scenery around using this lens even without a screen. Look at that. It's not because it's virtual, it's because you can actually see a real image if you stand at a point behind this. Is that clear? Is that clear? Everyone understanding this? Everybody up to date? Everybody understood this? Very important differences. Let's start with some problems. Okay, so cool. So Chilupuri, basically I'll tell you what. See, simple funda. Okay, forget this. If there is some mirror and the rays are going like this, they are not actually starting, but if you extend it backwards, they appear to originate from a point. Then that point is where the virtual image is. Second thing, if the rays actually meet at a point, that's where you will get real image. Now, for seeing a real image, there are two ways. One, you actually hold a screen. So if you hold a screen over here, you will see that image. But if you don't have that screen, the rays will continue going like this. And if you are standing over here, then these rays will enter your eyes and you will feel that the image has been formed over here. I hope this is clear. Is that fine? Is that fine? Okay, now let's solve this question. Cool. Now look at this. There is an object in front of this mirror, and in these four cases we want to figure out how will the image move. Let's take case one by one. So let's take this case when the object is going this side with a speed of 15 meters per second. If it is going this side with a speed of 15 meters per second, what will happen, guys? The image will obviously come closer with a speed of 15 meters per second. I hope this is clear. If object goes here, image will come here with a speed of 15. That's solution 1. Second, if the object goes this side with a speed of 15 meters per second, then the image will also go behind with a speed of 15 meters per second. In fact, the relative speed will be 30. The relative speed will be 30, correct. Speed wise it is 15. Yes, frame, it is similar to like a projector. So if the rays from a projector are falling on a screen, okay, that's where the real image is formed. But if the screen is not there, and if you go behind the screen, you can still see what has been projected from the projector. But that will be small and all that stuff. Don't worry. Okay, now if the object goes here with a speed of 15 meters per second, then understand even the image will go up with a speed of 15. I hope this is clear. And if the object goes down with a speed of 15, then also the image will go down with a speed of 15. Is this problem clear? Is this problem clear? Yes, is this clear? Yes, very good. Now I'll just change little bit. Instead of the object moving, I'll make the mirror move. Yes, instead of making the object move, I'll make the mirror move. Guys, we are going to start from the basic problems and we are going to go to higher level problems. And just like promised, we are also coming up with PYQ series. Yes, in all the subjects, Yes, the previous year question papers and the questions, strategies and different things before your first attempt. We are coming up with that. But just like we promised, we are first completing the syllabus. See guys, there is no point just solving questions if you don't know the basics. So that's why it's very important. Treat these things like a crash course on YouTube for all of you, so you can do proper theory revision, see all the formulas, see how to actually solve the questions before we start the PYQ series. Yes, we are there for all of you. Now, in the first situation, if the mirror, okay, let's do this. If the mirror is moving towards you with a speed of 15 meters per second, okay, then what will happen to the image? Think about it. For the mirror, okay, just think about it. From the mirror frame of reference, okay, from the mirror frame of reference, you will actually see the object coming like this with a speed of 15. Because mirror going close is same as when you sit on the mirror, object going towards it with a speed of 15. So, shouldn't the image also move with a speed of 15 with respect to the mirror? The image should move with a speed of 15 with respect to the mirror. But do not forget, the mirror is actually moving. For me, this is moving with 15 and I am myself moving with a speed of 15. So for you guys, think about it. If I move 15 meters and for me this moves 15 meters. So for you, how much has this moved? 30. Isn't it? Isn't it? Think about it. Think about it. For you guys, you are at rest. I am the mirror. I move 15 meters in 1 second. For me, this image moves 15 meters in 1 second. So think about it. As I moved 15 meters, the image also moved and it moved more with respect to me 15 meters. So totally it has moved 30 meters. So the actual speed of image will be 30 meters per second. This is very important. This is very important. A lot of people, get confused and they mark 15 only. So if the mirror moves, the image speed is twice. Keep this in mind. The image speed is twice. Keep this in mind. Okay, cool. Next, if the mirror moves away, with the speed of 15 meters per second, then what will happen to the image? Again, do the same analysis. Do the same analysis, you will get the same answer. If the mirror moves away, for the mirror, the object will move left side. The object will move left side with a speed of 15. If the object moves this way, the image should move this way with a speed of 15. Isn't it? Now think. I am the mirror. This is the image. For me, the image has moved 15 meters per second. And I, being the mirror, have also moved 15. So totally, how much did this image move? For me, it moved 15 and I moved 15. So totally, it has moved 30 meters per second, guys. So that is the answer. Again, twice the speed. Correct. Towards the right side. Yes. I hope, Prem, now it is clear. Just think first in the mirror frame and then move from the mirror frame to the ground frame. So you should be very, very clever with relative motion. If you are weak at relative motion, then probably you will get confused. Okay. Yes. To the right side. 30 meters per second to the right side. Yes, it will go away. Very good. Very good. Very good. Now, if this much is clear, last things. When the mirror moves up with a speed of 15, and the mirror moves up with a speed of 15, what will happen to the image? Come on, let me see how many of you can answer this really quick. How many of you can answer this really quick? What is the speed of the image, guys? Quickly. What is the speed of the image? Hi, Afreen. Thank you for all the love, Princey and others. 30? No. Think again. It is wrong. It is wrong. The speed is 0. Guys, the speed is 0. How will it be affected? Even if the mirror goes away like this, it is going like this. It's going like this. The image should be always in front of it, no? It should be always in front of it. So you are just sliding the mirror like this. The image will still be in front of you. There will be no change. 0, correct. No change. So same answer when the mirror is going like this. This kind of questions have come in JEE Advanced. This kind of questions have come in JEE Advanced. So guys, you need to be really, really careful about this. Okay? So think carefully. You would definitely understand this now. Understood? Clear? Are these questions very interesting? Yeah. Yeah, let's assume that mirror to be infinite. Yes. Correcto. Okay, cool. Let's go ahead to the next question then. Okay. A person standing in the center of a room of height 12 meters, yes, of height 12 meters, looks into the plane mirror fixed onto the wall. Then, what is the minimum length of the mirror for him to see the full length of the image of the wall behind of him? Very interesting question. So let me show you the diagram. It looks something like this. This is that mirror and this is the wall. Now, the question is, how much mirror do you need for this Pandu to see the complete wall, that red color wall which is there? He wants to see it. Thank you, Chilupari. Now, should I tell you one trick? Because a lot of people get confused. Some people by heart the answer. Oh, it is h by 2, h by 4, h by 10. But the moment the problem changes, then they don't know what to do because they have by hearted the solution. I'll tell you one very important trick. Whenever there is a mirror, replicate whatever is there in front of the mirror behind it. What did I say? Replicate whatever is there in front of the mirror behind it. Why? Because what does a mirror do? That's what it does. Whatever is there in front, it puts it behind in the virtual world. Doesn't it? So think of everything behind the mirror and then just forget that this mirror is there. Just forget for time being this mirror is there. Now think, most of you guys are wrong, let me tell you that. So Princey, what I did was, because there is a mirror, it reflects everything in front of it, behind it. So I forgot the mirror and I imagined the room is double the size without the mirror. Just think of it that way. Now, for this Pandu to see this red painted wall, all right, he wants to see this wall. So this is the wall's reflection. So think about it. The rays must reach his eye. So the rays must reach his eye. So something like this and like this. These rays must reach his eye. Now, this is the only part of the mirror which will be needed. Think about it. This is the only part of the mirror which will be needed. Even if this part and this part is not there. If this part and if this part is not there, it's okay. Because think of it this way. This wall's image will only need this part because the actual rays will come from here and get reflected like this. This is how the actual rays will come and it will get reflected into his eyes. So all I have done is replicated whatever was there here over there. If this much is clear, yes, it's like you are seeing, the wall through a hole. How much hole size do you need? So guys, he's standing in the middle of the room. So if this is X, shouldn't this be also X? If this is X because he's standing in the middle. So shouldn't this be 2X? And shouldn't this be 3X? Now, if this is X, this is 3X. Do you see triangles getting formed over here? I'll tell you which triangles. One triangle here, okay, one triangle here, and the other triangle here. So guys, shouldn't these triangles be in the ratio of 1:3? 1:3 because this is 3X, this is X. So think about it. Now, if this is H, how much should this be? H by 3 because 1:3. This should be 3 times smaller, that should be 3 times larger. No, it does. Yes, the final answer depends on the position of the observer. Since he was standing in the middle, that's why these relationships have come. X, X, 3X, 2X, etc. If you are standing somewhere else, you will see it somewhere else. And the answers will be different, Kirito and others. Yes, yes, Saurav, please tell. So, what is the actual height? 12. So, what should this h by 3 be? If this is 12, how much should this be? 4 meters. And that's what the correct answer is. Is that clear? Is that clear, everyone? Isn't this a beautiful solution? Isn't this a beautiful way of solving this? I have not written even one equation. Did I write even one equation? Any one formula, Pythagoras, trigonometry, nothing. Just pure logic, and I have solved this problem. Very good. Yes, 4 meters. Correcto. Beautiful. That's the answer. Let's go ahead to the next question. Beautiful question, guys. Thank you very much. Yes, 4 meters will be correct only if Pandu is in the middle, Princey. If you are at some other place, then it will be different. Saurav, why don't you again replay this part and maybe you'll understand it. Okay? Sometimes it can take a little bit more time than usual because it involves a lot of geometry. My request is please go back and you can again catch up, no problem. Okay, cool. Now, if you still want, you can still try and understand whatever I am explaining over here, no problem. So a ray of light is inclined at 50 degrees on the middle of one of the two mirrors arranged at an angle of 60 degrees between them. The ray touches the second mirror, gets reflected back to the first mirror, making an angle of incidence equal to how much? So let's understand what is happening. First, a ray hits the first mirror, okay, at an angle of 50 degrees, gets reflected and hits the second mirror. So then it touches the second mirror, gets reflected back to the first mirror. That's what is happening. So let's see what and all angles are given. First, let me show the normals. Let's see what and all angles are given. The first angle that is given out here is that this angle, okay, is 50 degrees. This angle is 50 degrees. So naturally, this angle is also 50 degrees because angle of incidence should be angle of reflection. That is one thing that is given. Next thing that is given, this angle between the mirrors is how much? 60 degrees. This is given to be 60 degrees. Now let's see how to solve this. Just like it doesn't matter whether it is Cengage question, Erodo question, HCV question, PVIQ question. The main thing is you should be able to solve it. It's not that you have to buy the solution and put it out here, right? So we are here so that we can solve it and understand it. That's the more important thing. It does not matter where this question comes from. So don't focus on other things. Focus on the session beta. Now, this is 50, this is 50. Let's see what else we can do. Interesting thing out here. This is 50. This total angle is 90, guys. Look at that dotted line and this mirror. It's 90 degrees, isn't it? So the complementary of 50 is how much? 40 degrees. So this angle must be 40. Isn't that correct? If that is 50, this must be 40. Okay. Now this 60 and 40 will make it 100. Isn't that clear? 60 and 40 will make it 100. And the total sum of the angles in a triangle should be 180 degrees. So if this is 100, this angle must be, think about it, 80 degrees. I hope this is clear. Correct. Now, next thing, this angle over here, that small angle that you can see over here, this angle or this angle, each of them are equal, but look at that, this angle is 90 degrees. This angle is 90, out of which this much is 80. So how much should be the remaining part? Remaining part should be 10 degrees because 80 plus 10 is 90 degrees, guys. I hope this is clear. Now, if you have understood till this point, think, if this is 40, this is 50. This is 50, how much will this be? This will be also 40 degrees, guys. This will be also 40 degrees. Isn't that correct? Now, look at this triangle. This triangle over here. This big triangle over here. Now think about it. What is this total angle, guys? What is this total angle over here? This total angle is 20 degrees, correct? Then also think, what is the total angle over here? This 50, 50, 100 plus 40, 140. So this is 140 degrees. So think about it. Think about it. How much should this angle over here be? This is 20, this is 140, 140 plus 20 is 160. And this must be how much? 20 to make it totally 180 degrees. So this angle is just 20 degrees. I hope this is clear. Yes, this should be 20 degrees. But that is not the final answer. The question is, what is the angle of incidence? So remember, angle of incidence is always measured from the normal. So this angle must be how much? 70 degrees. That is the final answer. So 70 degrees is the final answer over here, at which the angle, at which the ray is incident. Correct. Can I explain how you located 50 degrees? 50 degrees is already given in the question. This is already given in the question. So if this is the incident ray, this is the normal ray, then this angle is 50. So this is also 50 because it is reflected. Incidence is equal to reflected. I hope that is clear, Pravenshi. Yes, Puri Kundli has been found. The complete Kundli has been found in this diagram. So much of geometry. That's why geometry is very important. Clear? Shall we go ahead? So the answer is 70 degrees. Next question coming up on your screen. Thank you, Dinesh. Prem, why don't you do one thing? Please rewind. Even during a live session, you can just rewind back in the live session and watch the entire video again, Prem. I would advise you to do that because I have a lot of questions to cover. But still, if you don't understand something, you can definitely ping me on Instagram and I'll help you out, Prem. Don't worry. I'll help you out. You can just ping me on Instagram. Hello, Vishwajit. Join in. So think about this question. How will you solve this question? Very interesting question. Cool. Think about it. How will you solve this question? The question says there are two mirrors and arranged at right angles to each other. A ray of light is incident on the horizontal at an angle of theta. For what value of the ray emerges parallel to the incoming ray after reflection? So what should be that angle theta for which it emerges parallel to the incident ray? That's what the question is. Let's have a look. First, what and all is given? It is given that this angle is theta. This is incident. Okay. And this is the incoming ray. So the ray after reflection from the vertical mirror. This is the final ray. This is the final ray which is going to come out. They both must be parallel. So for what value of theta is it going to be? So here is the method to solve this. What I'm going to do is, if this is theta, this is obviously 90 minus theta, correct? And then if this is theta, obviously this is also theta. Why? Angle of incidence is equal to angle of reflection, correct? Then if I join this line like this, it becomes a right angle triangle, correct? It becomes a right angle triangle. Now in this right angle triangle, what will be this angle? Think about it. This angle over here will be also 90 minus theta because it's complementary, and this will be the angle of incidence for this mirror. So obviously the angle of reflection must be also 90 minus theta. Now the job is done. The job is done. I'll tell you why. Look at this line and look at this line. Are these two parallel lines? Are these two green lines parallel lines? Yes, obviously. And aren't these blue lines out here? This blue line over here and this blue line over here, aren't they making the same angle with the parallel lines? So shouldn't these two be also parallel to each other? Shouldn't these two be also parallel to each other? So the question is, for what values of theta do they emerge parallel? What is the value of theta I have taken? I didn't choose any particular value. I took a general value. That means it is valid for all the values. It's a general result. It is not dependent on theta. That's what the answer should be. The normals will intersect at 90 because this angle is 90. Look at this. They are arranged at right angles to each other. That is the reason why, since this is 90, this is also 90, hence this must be also 90. Okay, I hope that also answers this question, Kirito. I hope this is clear. Study buddy, yes, cool, yes, cool. Chalo, let's get going to the next question. I hope you guys are enjoying these questions. Let's go ahead. Now let's solve a question. Let's solve a question based on, multiple images. Very interesting question, guys. There are two mirrors parallel to each other and spaced 20 centimeters apart. A luminous point O is placed between them at a distance of 5 centimeters from one of the mirror. Then find the distance of the first nearest images from each other. Very important. Very good question. Let's see how to solve this. Let's say I call this mirror 1 and let's say I call this mirror 2. Haven't you ever stood between two parallel mirrors, especially at the barber shop or probably at the changing room in a mall or something, or a store where you buy clothes? There is a mirror here and mirror here, and you see multiple images getting formed as if you are there is an army of you. Haven't you experienced this? Yes. Oh, Ankit already says that he has seen it in a barber shop. Very good. Correcto. So guys, if this is the object and this is at a distance of 5 centimeter, you will see the image behind this mirror 1 exactly at a distance of 5 centimeter. This is image 1. And not just that, this object will also reflect, because it is at 15 centimeters from the other mirror. Remember, the total distance was 20. The total distance was 20. So if this is 5, this is 50. So this mirror will also form an image over here, and this distance will be how much? 15 centimeters. So now think about it. What is this total distance? 5 plus 20 plus 15. So 5 plus 20 plus 15, guys. It is 40 centimeters. That's the answer. Yes. By the way, understand, this is not the final set of images. This image will form the object for this mirror. Yes, this image will form the object for this mirror. It will reflect somewhere here. And this image will form the object for this mirror, and it will form the image somewhere here. And that image will again form the object for this mirror. Again, it will reflect there. And this will keep on happening infinitely. And you will have infinite set of images. Avantika, this is not out of portion. This is in portion. Who told you that this is out of portion? Somebody has told you that is wrong. Okay? Cool. So let's get going to the next question. So the answer is 40, like we saw. But now just imagine if the angle between the mirrors is such that it is not parallel. Avantika, we are not learning for boards. We are learning for JEE. This is a JEE channel. And in JEE, nothing has been omitted. Remember that. Okay? So it is there in JEE. So we are learning it. Okay? Okay. Cool. Now, if they are at an angle, then what will happen? Then what will happen? You will not see infinite images, something like this. Look at that. Some object is placed. There are two mirrors. You can see some images getting formed. There are some images getting formed. All distances won't be the same. They will be at different places. Magical paintbrush. Now we'll solve this question. And a lot of people by heart a formula. 360 by theta minus 1, 360 by theta plus 1, 360 minus 1 by theta, this greatest integer function. If theta is even, theta is divisible, non-divisible, some random things. Don't do all that. I'll teach you a simple technique. Imagine there are two mirrors. There is an object. The angle between them is 60. The question is, find the total number of images formed. The question is, no, Olvisha, that is not the correct answer. That is not the answer every time. That is why you need to be very careful. That is why I am teaching you a method. So, the object is here. These are the mirrors. I want to find how many images are formed. Do it within few seconds. I'll teach you the method. It's very simple. It will hardly take you less than a minute in the actual exam once you practice this. So, since the object has not been mentioned where it is exactly, so let us just assume that, this object is somewhere over here. Maybe this is 30 degrees and this is also 30 degrees. It doesn't matter. I'm taking it symmetric because it will be easy. Remember, the total angle has been given to be 60 degrees. Okay. Now let's do this one by one. Take this mirror M1. Take this mirror M1. For this object, the image will be formed 30 degrees behind. This is the object. The reflection will happen 30 degrees behind. Now 30 plus 30 plus 30 will be 90. So it should be perpendicular. So the object's image number 1 will be formed here, and this will be perpendicular. And this will be also 30 degrees. Cool? Next, this image will be the object for the other mirror M2. So this image will be the object for the other mirror. So where will this image be formed? Exactly at 90 degrees over here. Correct? So this will be I2 and this will be also 90 degrees. I hope this is clear. I hope this is clear. Now think about it. Think about it. If this is 30, obviously this is also 30, guys. Remember, this angle was 30. So then this angle opposite, all right, this and this should be equal. So this image will form an object for this mirror and it will be reflected on this side. Think about it. It will be reflected on this side over here and exactly at 30 degrees again, and this will be image I3. This will be image I3. I hope this is clear. So for this mirror, this object was reflected 30 degrees behind. So obviously this will be also 30 degrees. Now stop over there. Why? Because this image won't get reflected by this mirror, because remember, these are the two mirrors. This is the silhouette side. So the object or this image is now behind the mirror. So it cannot reflect itself. So stop over there. You cannot stand behind the mirror and expect a reflection to be formed. You have to stand always in front of the mirror. So that's why you stop over here. Pravenshi, there is no formula. I mean, even if you remember that formula, you will get confused because there are multiple cases and you will never remember it. I have been teaching for last 10 years. I know which formula works, which formula doesn't work. So use this method. It is very, very simple. Next, stop over here. Now, take mirror 2. Behind mirror 2, what will happen? This object's reflection will be formed at 30 degrees. This is image 1. This image will be reflected behind mirror 1. This is 30, 30, 30. Actually speaking, this was I1. Okay, just one second. This was 30, this was 30. Okay, and the reflection happened at 30. 30, 30, 30, 90. So the reflection must form over here because of mirror 1. So this is I2, correct? Now think about it. If this is 90 degrees and I know that this is 30, so obviously how much is this? 60. If that is 60, then how much is this? This is also 30. Okay, cool. So where will be the next image formed? Obviously I2's reflection will be formed over here and it will coincide with it. 30 here, 30 there. It will coincide with it. So totally how many images formed? 1, 2, 3, 4, 5. 5 images are formed. I hope this is clear. I hope this is clear. 6 is not the answer because these two images have coincided with each other. Very important. Is that clear? Is that clear, everyone? So that's how you solve these questions. So keep finding the reflections till the final image goes behind the mirror, and do the same thing for the other mirror till the image goes behind the mirror, and then just count it, and if something coincides, do not count it twice. Very good, very good. Sanjukta, I think you should study for minimum 5 to 6 hours apart from your school and regular classes. Okay, 5 is the answer. Now let's do problems on spherical mirrors, guys. Let's do problems on spherical mirrors. I'm pretty sure you know all these terms. Do you know all these terms? The radius of curvature, focal length, center of curvature, pole, principal axis, when it becomes concave, when it becomes convex, and all that. You would have studied this in 10th. This diagram is self-explanatory. Pole is that center point of that mirror. A line which is drawn from that pole is the principal axis. C is the center of curvature, which is the center of that curved mirror. So if you extend that mirror, it becomes a sphere. So that center of that sphere is center of curvature, and that radius of the sphere is radius of curvature. You know all of this, I'm pretty sure. Now for concave mirror, let me show you some applications. You might have seen this concave mirror, especially when you have to shave in your bathroom. Probably your dad's, or maybe in the hotel or something, might be using this. So this concave mirror has a small curvature, such that you will see a magnified image of your beard so that you can shave it properly. So it is used as a shaving mirror, and even dentists use it to see the cavities, or if there is some problem in your tooth. this is a concave mirror, guys. You will see a magnified virtual image under special circumstances. Yes, image is magnified under special circumstances, otherwise it is a real image. So this is a concave mirror, and I'm giving you all the ray diagrams in the session PDF so that you can revise it. This would have been done in your 10th standard. This was such a beautiful exercise. Place the object here, draw the rays, and see where the image is formed. I'm pretty sure you would have enjoyed this in your 9th or 10th standard, whenever it was. So when the object is at infinity, the image is formed at the focus. When the object is at the center of curvature, the image is inverted, real, and at the center of curvature. I'm pretty sure you know this. Yeah. And yes, 4 mark, easy question. And if you have the object at the focus, the image is not formed because it is formed at infinity, and other stuff over here like this. Only when your object is between the focal point and the pole, that's when the image is erect, magnified, and virtual. This is the scenario, guys. This is the scenario used by the dentist. So your tooth will be here, and the image of the tooth will be formed enlarged and virtual. That is why dentists use this. Okay, cool. So all this will be there in your session PDF. Please check it out. Let's actually go to some problems and some formulas. Now, very important thing, convex mirror applications. Have you seen this? Have you seen this in parking lots or at busy traffic junctions? Or even the rear view mirror of your car is convex in nature. Yes, the rear view mirror of your car is convex in nature because the convex nature makes sure that there is a wide coverage and many things are seen in your mirror, and the best part, the images are erect and virtual. Imagine convex mirror produce real image, then you'll have to take a screen to see it, and imagine if the images were inverted, then you will see everything upside down and you have to figure out what exactly is happening. Luckily, the convex mirror produces erect, diminished, and virtual images, which makes it a very ideal mirror for these kind of applications. Correcto. Now, for convex mirror, there is only one ray diagram which you should know. That is, if you place the object here, the image is formed here. You can see it is diminished, virtual, and erect. So the ray diagram looks like this. Again, this diagram will be there in your session PDF. Correct. Shall we go ahead? Guys, everybody knows this. Come on, all the minions, let me know here. Some minions, I think they have slept. Come on, everybody knows this, ray diagrams, yes or no? Come on, let me know, minions. Then I'll show you some problems and formulas which are exclusively for 11th and 12th standard. All right, come on, very good, Gayatri, Samira, Science Priya, Kirito, Dinesh, Magical, very good, Princey, very good, Srihari is crazy, very good, Samira, Chilupuri, yes, excelente, very good, Yalni, very good, Dani, chalo Karthik, let's get going then, Ankit, yes. Now the mirror formula, very important. 1 by V plus 1 by U is equal to 1 by F, and R is equal to twice of focal length. Both the formulas are important and everybody knows what these terms are. This is image coordinate. I will call it as the image coordinate. This U, I will call it as the object coordinate. That is a better word for this. And this will be the focal coordinate. That will be better. And this is the center of curvature coordinate. Now you'll be like, sir, everything is a coordinate. So where is the origin? The origin, keep this in mind, guys. The origin is the pole. The origin is the pole, and these are your axes. This origin is your pole. But which side is positive? Not right side. No, that's wrong. Right side is not necessarily positive. The side where the incident rays are appearing to go. If the incident rays are going that side, then that side is positive. If incident rays are coming this way, then this side is positive. In this diagram, incident rays are going that side. So positive X is over there. Understood? Now why am I saying coordinates? That's very important. Because imagine, just imagine, if this is let's say for example your object, and let's say this distance, if this distance is example 3 meters, I'm just giving you a random example, then what will be the value of u? Think about it, in the coordinate system, won't the coordinate of the object be -3? So that's why the value of u will be -3. That's why I'm saying, rather than remembering distance, think of it like coordinates, guys. Think of it like coordinates. Next, if I tell you example that this distance where the image is formed, where this is the image, example is at 7 meters, example, then the value of v, because the coordinate will be negative, will be -7. I hope this is clear. Next, similarly, imagine, okay, just imagine if this is the focal point, okay, and this is the radius of curvature, okay. Oh, by the way, I forgot to tell you, this f is the focal, I mentioned it over here, this is the focal coordinate, this is f. If this distance is, for example, 2 meters, then the value of f will be -2 meters according to sign convention, and r will be 2 times of -2. So how much will r be equal to? It will be 2 times of -2, which will be -4 meters. Now what does this -4 stand for? It gives you the coordinate of the center of curvature. So the center of curvature will be at 4 meters behind the pole. That's what it means. I hope this convention, this coordinate system is very, very clear. Think of these like coordinates, not as distances. Cool. Next, magnification. There are 2 types of magnification, guys. One is the magnification which happens laterally, and that is -v by u. That means if you have an object like this, the image is like this. So this magnification is the image height by the object height. So this is basically along the height what kind of magnification happens. There is another magnification which can happen. So imagine if this is your object, okay, and imagine the image is slightly wider. So this is the image. So the image width and object width has changed. Maybe the height also has changed. So this is the width of the object, this is the width of the image. So this kind of magnification which happens along the width is -v square by u square. And this magnification is nothing but the image width upon the object width. You should remember this as well. -v square by u square along the principal axis. Is that clear, everyone? Is that clear, everyone? I hope everybody has understood this. Cool. Shall we go ahead? Shall we go ahead? Yes. Next, image velocity. Very important formula. Very important formula. If you have a mirror like this, and let's say there is an object and maybe the image is formed here, then if VO is object velocity, VI is image velocity, then object velocity and image velocity are related by VI upon VO is same formula, -v square by u square. Same like, that magnification along the principal axis for the width. So same formula is there for this as well. So you should note it down. -v square by u square. Yes, this is not there in 10th. This is there in 12th standard. Yes, this is the 12th standard part. This velocity and image part. Okay, cool. Yes. Now let's solve some questions. Let's see how many of you can get this. Come on, quickly, guys. More 10 minutes. We'll solve some really cool problems. A point object is placed at a distance of 30 centimeters from a convex mirror of focal length 30. The image will be formed at. Now before doing anything, first draw the diagram. Without drawing the diagram, don't do anything. A point object is placed at a distance of 30 from a convex mirror. Okay, first draw a convex mirror, guys. This is that silvered side. This is the principal axis. Your object is over here and at a distance of how much? 30 centimeters. Now, where is the focal point for a convex mirror? Think about it. The focal point is over here. This is where F is. And the focal length is how much? Oh, that is also given to be 30 centimeters. Now, the rays from the object are going to come like this, that way. So if that is the way, then understand my coordinate system will be like this. This is my y-axis, this is my x-axis, this is the pole as well as the origin. Now you can start solving. Use the formula 1 by v plus 1 by u is equal to 1 by f. 1 by v I don't know. V is unknown. U, should I take it as 30 or minus 30? Look at the coordinate of the object. It is minus 30. So just put it as minus 30 here. Focal length, just put the coordinate of the focal point. It is plus 30. So put it as plus 30. So therefore 1 by v will be 1 by 30 plus 1 by 30. I've taken this term over there, which is 2 by 30, which is 1 by 15. Take reciprocal, so v will become 15 centimeters. That is the answer. So since v has come out to be plus 15 centimeters, it means that the final image will be formed somewhere over here. This is where the image is formed and it is behind the mirror. So hence 15 centimeters behind the mirror is the correct answer. I hope this is clear. Yes, very good. Some of you solved it before me. Very good, very good. So I hope you have also understood the explanation. Next, radius of curvature is 40 and the size of the image, which is real, is twice as that of the object. Then what is the object distance? Let's try and solve this. Okay, there is a concave mirror. Okay, let's do this question, guys. Think about it. There is a concave mirror. This is the principal axis and the size of the object, image is twice as that of the object. Okay, fine. The object is maybe here. This is our object and let's say this is our image and the height is double. Okay, and the distances are not given. Okay, but since the magnification is given, the modulus of the magnification is given to be 2. Okay, the magnification is given to be 2. That means modulus of minus v by u is 2. That means, think about it, the image distance is twice as the object distance. So think this way, guys. If I take this much distance as some length x, then this much distance must be 2x, correct? Because v by u is 2. So if object distance is x, image distance should be 2x. Interesting. Now I'll make use of this. In the formula, 1 by v plus 1 by u is equal to 1 by f. Oh, before that, I also need the focal length. Radius of curvature is 40. And if r is 40, remember r is 2f and r is 40. So focal length is nothing but 20 centimeters. But should I take it as plus or minus? Well, think for a concave mirror, the focal point is somewhere here. The focal point is somewhere here, right? Left side. So shouldn't it be negative? So this answer should be negative. Understand that. So focal length will be negative. In fact, r will be also negative. I hope this is clear. Correcto. Now solve this. 1 by v. Okay, 1 by v. So v is how much? 2x, but a negative sign. Do you understand why that negative sign? Because x is the length. So it could be 3 meters, 5 meters, I don't know. But the coordinate is negative. Plus 1 by u is minus x is equal to 1 by f, which is 1 by minus 20. Now this will minus will go and this will become 1 by 2x plus 1 by x is equal to 1 by 20. Next step, half plus 1 is 3 by 2. So it will become 3 by 2x is equal to 1 by 20. So flip it, it will become 2x by 3 is equal to 20. So 2 and 20 cancels, it will become 10, and x will then become 30 centimeters. So this should be the answer. Is that clear, everyone? I hope this is clear. I hope this is clear. Very good. Yes, that's the answer. Now let's solve this question. Let's see how many of you can do this. Slowly going to higher order problems. If x1 and x2 are the distances from the focal point, then what is the focal length of the mirror? What is the focal length of the mirror? Let's have a look. So what we'll do is we'll start with a diagram first again. So let's take a mirror randomly. Then let's take a focal point over here. The image formed is at distance x2 and the object is at distance x1. Okay, cool. So let's say this is the object, let's say this is the image, and let me mark some distances. The focal length, let's say, is d. This distance is d. This distance is x1 and this distance is x2. Okay, cool. Now, as per our coordinate system, this is x, this is y, this is the origin. Let's start solving it now. Using mirror formula again, 1 by v plus 1 by u is equal to 1 by f. Guys, just start solving, you will get it. It's very simple. 1 by v, think about it. What will be v? V will be the total, oh sorry, I think I marked x2 from the object. This was x2, guys, sorry, this was x2. Okay, now I think it should be fine. Okay, now what is image distance? It will be x2 plus d but with a negative sign. Think the total image distance or the coordinate will be d plus x2 but with a negative sign. So minus d plus x2. Cool. Plus 1 by object distance from here d plus x1 but with a negative sign. So minus d plus x1. What is focal length? It is d but just with a negative sign. So minus d. That's it. Now minus 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 goes, and take LCM, guys. Take LCM. That will be better. Minus has cancelled. So it will become d plus x1 plus d plus x2. The whole thing divided by d plus x2 into d plus x1 is equal to 1 by d. Now let's simplify this. Okay, I'm going to erase this because I'm not going to need this anymore. So on the numerator I have 2d plus x2. So I have 2d plus x2 plus x1, and if I cross multiply, it will be into d. This will be equal to this into this. So that will be d plus x2, which will be, okay, just let me put it over here, d plus x2 into d plus x1. Now simplify this, guys, it's not that difficult. So it will become 2d square plus dx2 plus dx1 is equal to d square plus dx1 plus dx2 plus x1 x2. Now see which and all terms will get cancelled out. dx2 dx2, dx1 dx1, d square and 2d square mein se only 1d square will remain. So you can clearly see what has remained. D square is equal to x1 x2. So d is root of x1 x2. What is d? Focal length. That is the answer. Correct. Some of you got it. Just check it out. What should I check? x2. Everything is fine. Dinesh, I guess. Very good, Saurav. If you are able to solve, very good, very good. Keep it up. Looks like you have understood everything. Very good. Keep it up. Keep it up. So that's the answer. Next and the last question for today. Hi Samira, join in. Last question for today, guys. Okay. Last question for today. When an object is kept at some distance, the image formed is at 10. If the object is moved with a speed of 9, the speed of the image will be at that instant. Jagdish, whenever the need dates are announced, don't worry, we will tell you. So here is the way to do this. Remember, I just told you image velocity upon object velocity is minus v square by u square. Minus v square by u square. Correct? Now, if you are talking about speeds, so we should forget the minus sign. So image speed, I do not know. Object speed, is it given? Yes, the object moves with a speed of 9. So 9. And modulus of this, v is image distance. Do I know the image distance? Yes. The image is formed at a distance of 10. So 10 square by u. U is, where is u? Yes, object is kept at a distance of 30. So it is 30 square. I hope this is clear. Now this is as good as saying this is 1 by 3 whole square, which is 1 by 9. 9 cancels. Image velocity will be 1 centimeters per second. So that is the answer, image speed. I hope this is clear. I hope this is clear. Understood, guys? Understood? I hope this is clear. Very good. Excellent. Now, this is your homework question for today. You have been asked to design a shaving mirror with so and so data. What should be the radius of curvature of the mirror be? That's the first question for homework. Second question of homework, a car is fitted with a convex rear view mirror. Somebody is overtaking. Find the speed of the image as seen by the car, relative frame. Now remember, guys, on Friday we are going to have advanced and pre-IQ questions, previous year questions combined. Today I have laid the foundation for reflection. Tomorrow we are going to lay the foundation for refraction. And then on Friday we are going to have a big session. So you need these basics for solving those problems on Friday. Very important. So very important. Yes. And I'll be posting all the answers on our Telegram group. So go ahead, follow the Telegram group. It's there in the description box below. In case you have not joined it yet, click on the link. And remember, the crash course starts every Monday. So if you have to, prepare and give a boost to your performance for the last 30 days, so please consider this crash course, which has 45 two-way interactive sessions with master teachers and class teachers in the class to solve your doubts. And complete syllabus will be revised 11th and 12th both, along with test series and discussions, and you will get doubt facility from morning till night, and also special sessions by Anand sir and Pulkit sir to motivate you and giving strategies just before the examination. So all of this, all these details are given in the link in the description box. Go ahead, check it out, and the course is available for 10,000. But if you use this coupon code SHCC21, then you get it for 8,000 rupees. So use this coupon code to avail the discount. So remember, the last batch has started from 18th of Jan. You can still watch the replay. In fact, even if you miss a class, you can still watch the replay. Let me tell you that. So if you have missed the bandwagon, guys, join it now, because you're just one day late. You can watch the replay and cover it up. So do not miss this opportunity. And show your support by hitting the like button if you have not done it, and if you have not subscribed to our channel, please hit the subscribe button out there for getting all the important updates on our channel. Thank you, Science Priya, Aishwarya, Krito, Princey, Ankit, Karthik, Dinesh, Albert, Ankit, Gayatri, Yogesh, Ami, Jyoti, Asmi. Thank you guys very much for a lovely audience, being a lovely audience out here, and keep coming. See you again tomorrow at 7 o'clock. Bye bye, take care, keep studying and keep learning from Enthuse.